I'm Michael Langley, and this is a astronomy understanding sunshine educational video project. And I'm going to be doing it on the types of electromagnetic waves the sun produces. The first one, radio. Radio waves have the longest wavelengths in the electromagnetic spectrum. They range from the length of a football to larger than our planet. Heinrich Hertz proved the existence of radio waves in the late 1880s. He used a spark gap attached to an induction coil and a separate spark gap on a receiving antenna. When the receiving antenna picked up waves created by the sparks of the coil transmitter, sparks would jump its gap as well. Hertz showed in his experiments that these signals possessed all the properties of electromagnetic waves. The next one is micro. Microwaves are a portion or band found at the higher frequency end of the radio spectrum, but they are commonly distinguished from radio waves because of the technologies used to access them. Different wavelengths of microwaves grouped into sub-bands provide different information to scientists. Medium-length C-band microwaves penetrate through clouds, dust, smoke, snow, and rain to reveal the Earth's surface. L-band microwaves, like those used by a global positioning system, aka GPS receiver in your car, can also penetrate the canopy cover of forests to measure the soil moisture of rainforests. Most communication satellites use C, X, and Ku bands to send signals to a ground station. The next one is infrared. Infrared waves. In 1800, William Herschel conducted an experiment measuring the difference in temperature between the colors in the visible spectrum. He placed thermometers in each color of the visible spectrum. The results showed an increase in temperature from blue to red. When he noticed an even warmer temperature measurement just beyond the red end of the visible spectrum, Herschel had discovered infrared light. The next one is UV. Ultraviolet or UV light has shorter wavelengths than visible light. Although UV waves are invisible to human eye, some insects such as bumblebees can see them. This is similar to how a dog can hear the sound of a whistle just outside the hearing range of humans. The next one is X-ray. X-rays are very high frequency waves and can carry out a lot of energy. They will pass through most substances, and this makes them useful in medicine and industry to see inside things. Some types of nebula give off X-rays by stars and strongly. An X-ray machine works by firing a beam of electrons at a target. If we fire the electrons with enough energy, X-rays will be produced. Last but not least, gamma. Unlike optical light and X-rays, gamma rays cannot be captured and reflected by mirrors. Gamma ray wavelengths are so short that they can pass through the space within the atoms of a detector. Gamma ray detectors typically contain densely packed crystal blocks. As gamma rays pass through, they collide with electrons in the crystal. This process is called Compton scattering, wherein a gamma ray strikes an electron and loses of energy, similar to what happens when a cue ball strikes an 8-ball. These collisions created charged particles and can be detected by the sensor. Hope you enjoy, and that's all.